guys. So if you look up here, the question he is asking up here, describe a test, uh, reagent and observation that would distinguish compound C from compound F. Okay, so compound C आपका पीछे बना हुआ है. If you look at the back, compound C is present. This one. This is the compound C. So I'm going to draw the compound C. So have a look up here. This is the benzene. This is COCH3. ओके, ये मैंने बना दिया. इसको मैं दोबारा से इसके साथ अब शो करवा रहा हूँ. दोनों में डिफरेंस चेक करें और मुझे बताएं कि दोनों को कैसे हम लोग डिफरेंशिएट कर सकते हैं. दिस इज सी एंड दिस इज एफ. एनीवन गॉट द आइडिया? ये A1 से रिलेटेड है. ओके, आई एम गोइंग टू टेल यू अबाउट इट. In your A1s you have done a test which is called as the triiodomethane test. याद आया? Triiodomethane test, and this one is called as the iodoform test. इसको सुन लें एक बार दोबारा से, क्योंकि ये अगले चैप्टर में दोबारा से आने. Iodoform test. So any compound, my dear, if it contains CH3, C double bond O, and it is continued only in the aldehyde and ketone. Aldehyde and ketone. And the second compound, that is CH3, COH and H. Okay, this thing is present in the alcohols. So if any compound which is aldehyde, ketone or alcohol and contain these two groups, so on those compounds a test that is being done, which is called as the triiodomethane test. Triiodomethane test के reagents क्या होते हैं? Okay, the reagents, they are aqueous iodine and plus aqueous NaOH. ये दोनों चीजें जो है वो इससे होती है. हम लोग करते क्या है? लेट्स सपोज माय डियर स्टूडेंट्स, हमारे पास ये टेस्ट ट्यूब है. इस टेस्ट ट्यूब में आप लोग सैंपल ऐड करनी है. जस्ट पुट द सैंपल इन द टेस्ट ट्यूब. ओके, एंड देन ऐड aqueous iodine inside it. Aqueous iodine, you know that it's brown in color. So when you add the aqueous iodine inside it, so the color that will become brown up here. Okay, now what should you do? You should add another reagent, sodium hydroxide. Sodium hydroxide drop by drop. Okay, so when you add the sodium hydroxide drop by drop, what would happen? Here you will see the yellow precipitate form. So these yellow precipitate form, my dear, yellow precipitate. Okay, so these yellow precipitate are of CHI3. Okay, and these are called as the triiodomethane. Okay, और ये तभी बनेंगे when you got these two groups in the compound. So if you look in the compound C, my dear, you got CH3CO. Okay, CH3CO is present up here, and this is that ketone. Okay, whereas if you look this one, this is ketone, but this one CO is attached with CH2, not with CH3. So it means कि इसके ऊपर हम लोग ये टेस्ट जो है वो लगा सकते हैं. So reagents that would be aqueous iodine and aqueous NaOH, and observation with C क्या होगी? Yellow precipitate form. And observation with F क्या होगी? No yellow precipitate form. और भाई इसमें वो ग्रुप नहीं है मेरे जान. CH3 के साथ C डबल बॉन्ड O नहीं है. उसमें CO CH2 के साथ जुड़ा हुआ है. कह भी रहा हूँ अकेला बना के दिखाऊं यार, क्या तुम कर रहे हो? ये देखो भाई, ये CH3, ये CH2 है, और आगे ये CO है, तो C डबल बॉन्ड O, और आगे ये बेंजीन है, लाइक दैट. So it means if you look, this C double bond O is attached with CH2. It's not attached with CH3. So for this test, the C double bond O should be attached with CH3. I told you right now. अब मुंह से बोल तो पड़ा, सारे ला रहे हैं, पता चल गया. But guys, did you get it? Online students,
जी सर.
have a look up here. This is the compound F, and we got the compound C backward. C. This is compound C. This one. Okay, so I'm going to draw the compound C. This is benzene. This is C. CO means C double bond O and CH3 like that. So this is compound C. Okay. So now what I'm going to do. The question is asking. The question is asking. Describe a test, a reagent and observation that would distinguish compound C from compound F. So this is compound C and this is compound F. Okay. So you want to distinguish both of them. Both are ketone partner. If you look, this is ketone and this one is ketone as well. Okay. So if we want to distinguish them, I told you in the A1 there is a test which is called as the triiodomethane test. Triiodomethane test. This test is also called as the iodoform test. And this test is employed for those compounds which are having CH3 attached with C double bond O and the chain is continuing. And this thing should be present in aldehyde and ketone only. Aldehyde and ketone only. Okay. The second thing, CH3, COH and H. So this one is continuous. So this one is, my dear, alcohol. Okay. So if any compound, aldehyde, ketone or alcohol got these groups, these things present in them, on them we apply a test which is called as the triiodomethane test. So the reagents for triiodomethane test, what are they? They are two. The first reagent, that is aqueous iodine, and the second reagent, that is aqueous sodium hydroxide. Okay, so these two are the reagents. So what should you do? First of all, you should take the sample C or F in a test tube. Okay, now add aqueous iodine in. This is the sample we have added, and then add aqueous iodine in it. So when you add the aqueous iodine in it, okay, so what would happen? Aqueous iodine, that is brown in color. Okay, so this whole solution, that would become brown. Okay, that would become brown. Now the second reagent, sodium hydroxide, we should add it drop by drop. Sodium hydroxide drop by drop. Okay, so when you add the sodium hydroxide, if it contains this group or this group, so what would happen? The yellow precipitate they would form within the test tube. The yellow precipitate, yellow solid. Okay, so these yellow precipitate, my dear, okay, they are triiodomethane. These are called as the triiodomethane. Okay, and when they are formed, if you got these two things, okay, these two. So if you look up here, this one contains this group, Partner. This group is present. So on C, this test could be employed, whereas on F, CO is attached with CH2, not with CH3. CO is attached with CH3 up here, but here CO is attached with CH2. So no triiodomethane test could be employed for compound F. Did you get it now?
Yes, sir. Thank you.
Okay, do question number 2. Part A, you have to complete this whole part. What the reagents and condition I need to change the benzene into chlorobenzene. So just write it. Just giving you 1 minute. Hurry up. Okay, my dear. So he's saying state the reagent and condition needed to convert benzene into chlorobenzene. Okay. So benzene into chlorobenzene. So you should take the reagent. So the reagent that should be
Chlorine and
the
AlCO3.
it's AlCl3. Okay. And just like that, bromobenzene, the reagent, that is bromine. And the catalyst, my dear, again, that would be AlCl3. Nitrobenzene, the reagent used up there, that is HNO3, okay, and whereas the catalyst used up here, that is concentrated sulfuric acid H2SO4.
सर कैटलिस्ट लिखना से मीटर नहीं ना खाली वो भी लिखते हैं काफी जैसे एनसी का खाली लिखने वाली जैसे
नहीं वो पूरा लिखो भाई, catalyst है वो. Okay guys, now complete this table please. B part 1 and 2 and complete this diagram. Hurry up. So if you look up here, first of all, this is the abnormal electrophile. Sir, just look up here. This is the abnormal electrophile. It is going to attack on the benzene from the ring towards the positive ion. Just make a curly arrow. So after that, what would happen, my dear? This is the benzene. The ring would be extended to the 5 carbons, positive charge. A would be attached up here, and this thing is having the hydrogen now. From the hydrogen, the electrons are given back. Okay, so H positive would come out, and the A positive is actually NO2. So it means A positive is actually NO2 positive. Okay, draw the structure of the intermediate. So I have drawn this structure. Did you get it? Yes. Online students, did you get it?
Yes, sir.
Yes, sir.
Okay, my dear. Now move on this question. Anyone of you could tell me, this is nitrobenzene, bromination. So if I'm going to add the bromine in it, where should I attach the bromine? Come on. This NO2 is which directing group? I told you yesterday. 3, 5 directing group. So bromine would be attached on the position 3. Okay. Now if you look at the next question, this one, my dear, NH2, it is having the single bond. So single bond things, there are 2, 4, 6 directing group. Okay. So we should make this whole compound again NH2, and here we got carboxylic acid as well. So with respect to this group, 2 position is that, so chlorine would be attached up here, and this carboxylic acid is 3, 5 directing group. So according to this one, 1, 2, 3, so this one is third position according to carboxylic acid. So according to amine, it is on second position, and according to carboxylic acid, it is on third position. Did you get it?
Yes, sir.
A scheme made up here. So I'm going to discuss that scheme for you. Some of the things that we have to discuss in the later chapters, and some of the things they were present in your A1s. So everybody just look up here. We are not going to discuss the answers. First of all, I'm going to discuss this whole scheme for you, that how these things they are formed. Okay, have a look from benzene to nitrobenzene. Muskan, what the reagents we should use and what is the type of reaction up here?
Electrophilic substitution.
Yeah, exactly. I told you benzene always undergo electrophilic substitution. This is the whole chapter we have studied and people are not talking. It's the electrophilic substitution, and this electrophilic substitution NO2 is attached. So it means the reagents, that is HNO3, and the condition that is concentrated sulfuric acid. Okay. Now, if you look up here, this NO2 has been changed into NH2. So this is the new concept for you. Everybody just listen it. Everybody just listen it, guys. Let's suppose this is the nitrobenzene. Okay, NO2. If you want to take out the oxygen and put the hydrogen up here, so what you have to do, you have to do the process of the reduction. So this process is actually the reduction, because loss of oxygen is reduction and gain of hydrogen is also reduction. So reduction that is carried out, if you want to change NO2 in NH2, you use thin is SN plus concentrated HCl. Okay, so that would form what they will do, it is going to put the hydrogen up here. Okay, so hydrogen and oxygen, they are going to form the water. Okay, So this is nitrogen, this hydrogen, and this oxygen that form the water. H2O, we got the two oxygen up here, two water up here, two water. Now this nitrogen is alone. With that nitrogen, the two hydrogen would be attached. So two hydrogen up here and four hydrogen up here. So total six hydrogens they are used. So always keep remember this reaction we have to study in the chapter later. But I'm telling you up here. Okay. So if you want to change NO2 into NH2, keep remember you should use thin plus concentrated HCl, and this is the reduction. And in the reduction, what would happen? The oxygen would come out, okay, and hydrogen would be at that place. Now the next thing, my dear, if you look up here, this is carboxylic acid. This one has changed into acyl chloride. So you have done it in your AS level that carboxylic acid has got OH group. And if you want to change, replace any OH group with a Cl, so you should use PCl5, PCl3, SOCl2, and HCl, okay, in the presence of anhydrous zinc chloride as a catalyst, okay. So I'm telling you all these reactions one by one. Have a look up here. Let's suppose this is ethanoic acid, CH3COH. So what does the PCl5 do, my dear? PCl5 is a reagent that takes first of all one hydrogen from here and gives its chlorine to form HCl, and then this P, this one O and 3Cl from here, they will form POCl3, and we get CH3, C double bond O, and one of the Cl is remaining, it would attach up here. So this one changed into acyl chloride. So if you want to replace the OH with a Cl, this is the first reagent, PCl5. Did you get it? Sorry?
Yes, sir.
कौन सा ये वाला? This is okay. The second reaction, CH3, C double bond O and OH. If you want to do the reaction with PCl3, in the PCl3, what would happen? The three molecules of this thing are used. So you got H3, H3, and then P, and then O. They are three as well. So O3. So phosphorus acid is formed, and you got three molecules of this CH3, C double bond O, and you got three chlorine. So three chlorine would be attached up here. So again, my dear, this acyl chloride is formed. So this is the second reagent. The third reagent use CH3, C double bond O and OH. So you use SOCl2. SOCl2, my dear, what is its do? H and Cl, they are going to form HCl, and this SO and O, that is going to form SO2. Okay, and CH3, C double bond O and Cl. Okay, so this is the third reaction which is used to replace the OH with the Cl. Okay, and the last reaction, my dear, have a look up here, CH3, C double bond O and OH. If you want to replace it with Cl, so put HCl in the presence of anhydrous zinc chloride as a catalyst. So what would happen? The H and OH from here, they will form the water, and you will get CH3, C double bond O and Cl. Okay. So these four reagents, my dear, PCl5 is the first one, PCl3 is the second one, SOCl2 is the third one, and HCl is the fourth one. So these reagents, they are used to replace the OH with the Cl. So you should know these reactions, these are also present in the A1s and they are also present in the A2. Did you get it, guys?
Yes, sir.
Just take a copy of it so that you can memorize it. If you want to replace the OH with Cl, and that OH is either carboxylic acid or either alcohol. If you want to replace the OH with the Cl, so you could use these four reagents, PCl5, PCl3, SOCl2, and HCl in the presence of anhydrous zinc chloride as a catalyst. So can I move to the next one? Can I love this one?
Yes, sir.
Okay, my dear. Now this is the acyl chloride and this is the phenylamine. So if you look up here, both of them they would react how? Let's suppose this NH2, I'm going to make its hydrogen separately like that. Okay, and this is the acyl chloride. I'm going to draw this acyl chloride up there, CH3, C double bond O, and Cl. So this H and this Cl, they will form HCl. Okay, so HCl would be generated, and this whole thing would be attached with this one. So you look, this is attached up here. Did you get it? So it means NH, and this one would be attached with this thing, then C double bond O and CH3. So this thing is written up here. Everyone got it? Which one? It's not the hydrolysis. ये hydrolysis नहीं है मेरी. What is this? बताओ जरा मुझे क्या हो सकता है ये आपका amide बन गया ऐसे amide की formation में. This is the formation of amide. और इसको जो है वो हम लोग क्या कहेंगे भला? मैं बताता हूँ इसको हम लोग न्यूक्लियोफिलिक सब्स्टिट्यूशन ही कहेंगे. Why? Because if halogen is present in any compound, so that would undergo the nucleophilic substitution. Okay, guys, did you get it? Now, if you look up there, you have to complete this one. If you look up there, the NO2 is attached, so you should draw the NO2 positive up there, make a curly arrow towards it, and then draw it towards the 5 carbon, NO2 attach up here, hydrogen up here, and then send it back to it, and then you got H positive up here. What type of reaction is reaction 2? So we discussed all about these things. Okay, guys, any one of you could tell me about this one? If I want to change this one into this one, what the reagent should I use and what type of reaction is this? Come on. बेंजीन के अंदर कौन सा रिएक्शन होता है?
Electrophilic substitution.
Electrophilic substitution. Thank you so much, my dear.
HNO.
Electrophilic substitution. And what are the reagents up here? If NO2 is attached,
HNO3 and concentrated H2SO4.
thank you so much. And concentrated sulfuric acid. भाई वही बता रहा हूँ ना. This CH3, if you look, this is present on position 1. So the upcoming group they would attach on position 2, 4, or 6. Have a look. This is attached in the position 4. Okay. Now the next thing, this CH3 has changed into carboxylic acid. I told you last time that alkyl benzene undergo the oxidation reaction. So I'm going to draw the hydrogen like that. So I told you save one carbon and hydrogen attached to it, and join all the other hydrogens with the oxygen to form water and carbon dioxide. So here we got only hydrogen, water is formed, and what is being left? Carbon and hydrogen is left. So with this carbon you attach oxygen, and H you attach oxygen, so carboxylic acid is formed. And what are the conditions for it? This one is acidified potassium magnate. Okay, and the conditions are heat under reflux, and this type of reaction is oxidation. Okay, now have a look up here. This NO2 has changed into NH2. Anyone can tell me? Reduction. What the reagents? 10 plus concentrated HCl. Okay, and now if you look up here, this is carboxylic acid and this is the ester. So carboxylic acid react with the alcohol. So the alcohol got the 2 carbons. Okay, so this one would be ethanol. CH3, CH2, and OH. Okay. So you use ethanol, and this is the carboxylic acid. They would form the ester, and with that, concentrated sulfuric acid is used as a catalyst and heat under reflux. Okay, did you get it?